Okay, part two. Stuff just takes a long time. Write a polynomial function of minimum degree in standard form with real coefficients given the zeros and multiplicity. Now this is the key. Multiplicity means your degree is 3, which means I take that 0 and I write it like this. F of x equals x minus 1, x minus 1, x minus 1. Now, yes, I could have written that x minus 1 and then put a cubed up here, but this is basically saying, hey, you got to multiply it all out. That's why this takes so long. Now, multiplicity 1 is just x minus 3. And now we just get going. I'm going to start here, and I'm going to go out. So FOIL it. X squared outside inside minus 2x last plus 1. Do the same thing with these two binomials. X squared outside inside minus 4x plus 3. And now I've got a 3 by 3 situation. Try to squeeze it in here. And so I get x squared minus 2x plus 1, x squared minus 4x plus 3, x to the fourth minus 2x cubed. Uh-oh. Hopefully I didn't make this too small. Negative 4x cubed, 8x squared minus 4x, 3x squared minus 6x, and then 3. Now I'm going to write this in descending order, so I'm going to get f of x equals x to the fourth, here's some like terms, minus 6x cubed, here's a bunch of like terms, so you get 11, 12, x squared, minus 10x plus 3. And there it is. A lot of work. All right, let's read into this one. Give ourselves some space. So negative 1 is one of my zeros, but the multiplicity is 2. It means it shows up twice. So I'm going to go x plus 1, x plus 1, and now here comes the twist. That is what's called a complex zero. Therefore, its conjugate also exists. What's a conjugate? Well, it's the minus version or the plus version. If you're not certain about this, look, x minus 2, x plus 2, these are considered conjugates. So, if this is multiplicity 1, then I'm going to have to do one of those weird things where I go x minus this whole thing, negative 2 minus I, but then you're going to have to remember that sneaky darn little rule, and therefore negative 2 plus I needs to pop into your head as another zero. Why don't they just list it? I don't know. It's just a tricky little math moment, so you got to hang tough. So it's x minus this 0. So it's negative 2 plus I. And now we've got a whole bunch of work to do. Let's start with the easy part, this. So FOIL it out. X squared outside inside would be 2x plus 1. All right, so that's from that. Now for this. This would be x plus 2 plus I. This would be x plus 2 minus I. And I am all about these 3 by 3 boxes when I get these bigger ones. So x2I, I think it really helps prevent a silly mistake. So x squared 2x ix, 2x 4 2I, negative ix. By the way, alphabetize these when it gets messy. And that way like terms will pop up easier when you're looking for them later. And here's a negative I squared, which is just the same thing as negative 1, which is just 1. So, looking for like terms, I got x squared. I'm going to try to squeeze that in here. I got 4x right here. And these cancel. These cancel. 4 plus 1 is 5. And so really what I need to do And again, I don't know if I'll be able to squeeze this in here, but I'm going to try. I've got another 3 by 3 situation. So x squared 2x1, x squared 4x5. This would be x to the fourth, 2x cubed, x squared, 4x cubed, 8x squared, 4x, 5x squared, 10x, 5. And so my final answer would be g of x equals, start with the highest powered term, so that's gone. Start adding your like terms up, 6x cubed, those are gone. 8 plus 5 plus 1 is 14, x squared, those are gone. Then I get 14x, those are gone, and then plus 5. And there it is. There it is. All right, that's a lot of work. And then we come in for a landing. Okay, this is just to check your understanding of this rascal. So this is a yes or no question. Is it possible for a cubic? What does that mean? There's going to be 3 roots. What does that mean? 3 zeros. What does that mean? There's going to be 3 answers. To have roots, remember roots, zeros, answers, interchangeable. 2 and 2i. They're implying that they're the only roots. And here's the thing. If this is a 0, we say, okay, there's 1. If this is a 0, then there's 2. Well, wait a minute, there needs to be 3. So my answer is no. It's not possible for the cubic polynomial to have the only roots 2 and 2i, because a third one would be negative 2i. Essentially, it's 0 plus 2i, and then its conjugate, 0 minus 2i. So it's a little tricky. How about this one? Is it possible for a quartic, so we're looking for 4 zeros, to have roots 1, 2, 3, 4. Now before you go, yep, but if this is one of my zeros, then wouldn't it also be, so this is 0 plus 2i, so the conjugate would be 0 minus 2i, and that would give us a total of 5 roots. So this one would be no. Okay. Example 7, my mind's starting to wonder if it really is implying only roots. If it's saying, is it possible for a cubic polynomial to have at least these 2, then the answer would be yes. But I think it's implying only roots, this and this, because they want you to imagine the conjugate and then go, aha, no, there's another one. So anyways, I don't want to confuse you. They just want you to understand the conjugate rule. This one says, if a quartic, so they're saying there better be 4 zeros, which means roots, has roots negative x plus 4i, negative 7 minus square root of 5. What are the remaining roots? Well, what's the conjugate of this? Well, remember, you got to keep it simple. If I have x plus 2 and x minus 2, those are considered conjugates. In other words, these are the same, but these are opposites. So this little negative x is meant to throw you a little bit, but here's the thing. The conjugate of that would be negative x minus 4i. And what's the conjugate of that? Well, that'd be negative 7 plus the square root of 5. And that's it. All right. A lot of work, but most of it's kind of busy work. Good luck.